Hello everyone, Abdul here, and welcome back to Eedemy, where we make electrical engineering as clear as a well-labeled panel. Today we're bringing you a simple and clear guide to one of the most important components in electrical control, the contactor, the switch that doesn't get enough credit. In this episode, we'll dive into what a contactor actually is and how contactors are designed to work, how contactors are represented in schematics, and how to read a contactor nameplate, where these components show up in the real world, and how to select the right contactor for your needs. For more great content, don't forget to subscribe. Let's power this lesson up. What is a contactor? A contactor is like a remote-controlled heavyweight champ in your electrical system. Instead of flipping a massive switch manually, you just send a small control signal, and the contactor does the heavy lifting. Its job? To switch high-power loads like motors, lighting banks, and heaters on or off safely and reliably. It's fast, durable, and designed to withstand high currents without breaking a sweat. Isn't this just a relay? Good question. Well, kinda. A relay is like the skinny intern switching lights on and off. A contactor is the big bodyguard switching giant motors without breaking a sweat. Same idea. Both are switches controlled by electricity, but contactors are heavy-duty versions built for bigger jobs, while relay controlling small circuits like lights, alarms, or simple automation. Very different league. So contactor is specially designed to switch high-power circuits on and off, safely, quickly, and repeatedly. Main uses: starting heavy-duty motors, managing industrial machines. Anywhere serious power needs serious control, you'll find a contactor. Components of a contactor. Inside, it's pretty straightforward. A coil that creates a magnetic field, a set of spring-loaded contacts, and often some auxiliary contacts for additional logic. So when that coil is energized, click, power flows through. When the coil is off, clack, the contacts open and the power stops. First, the power input terminals, 1, 3, and 5. These are the main input terminals where you connect the incoming power lines, usually L1, L2, and L3 for a three-phase system. Next, the auxiliary contact terminals, 13 and 14. These are normally open auxiliary contacts. They close when the contactor coil is energized, perfect for sending signals or controlling indicators. 21 and 22. These are normally closed auxiliary contacts. They open when the contactor is activated, used for safety interlocks or control circuits that need to shut off. Then the power output terminals, 2, 4, and 6. These are the main output terminals, connected to the load, like motors or large machines. When the contactor pulls in, power flows from the inputs to these outputs. Finally, the coil terminals, A1 and A2. These are the control coil connections. Apply the control voltage here to energize the contactor and close the main contacts. So here's the best part. These numbers are almost the same across all manufacturers. Learn it once, and you'll be ready for any contactor anywhere. Inputs are at 1, 3, and 5. Outputs are at 2, 4, and 6, 6. The control coil, the brain, is at A1 and a 2. And the rest, that's the auxiliaries, living at 13, 14, and 21, 22. Let's start with the coil, marked A1 and A2. This is your control input. When you apply the control voltage here, the coil gets energized. It creates a magnetic field, and that magnetic force pulls the internal armature. This is the moment the contactor comes alive. It clicks, and everything starts moving. Next, the main contacts, L1 to 1, L2 to 3, L3 to 5. These contacts are usually normally open. When the coil energizes, they close firmly, allowing the big current to flow through the contactor, powering motors, lights, or any heavy equipment connected. And don't forget the auxiliary contacts. They handle the small, smart stuff. These are perfect for sending signals, turning on indicator lights, or creating safety interlocks to protect your system. In short, coil A1 to A2 brings the contactor to life, main contacts carry the heavy power, auxiliary contacts manage the brains and safety. See, contactor symbolization in schematics. So how do you recognize a contactor in a schematic? Quick symbol tips. A coil, 2 vertical lines or a box. No contact, 2 lines with space in between. NC contact, same lines but with a diagonal bar showing it starts closed. Simple once you get the hang of it, like reading emojis for electricians. Let's go through the common information on a modular contactor nameplate using the WAC4940 modular contactor as an example. How to read a modular contactor nameplate WAC4940. This is the product name, i.e. 40A. This indicates that the rated operating current of the contactor is 40 amperes. UE 400V, the rated operating AC voltage is 400 volts, which specifying the voltage level at which the contactor is designed to operate. UI 500V, the rated insulation AC voltage is 500 volts, which is a safety measure to protect against voltage surges. UI stands for rated insulation voltage. It tells you the maximum voltage the contactor's insulation can handle safely during normal working conditions without any risk of breaking down. In simple words, UE protects the inside from regular voltage stress. UIMP stands for impulse withstand voltage. It shows how much sudden, high voltage spike the contactor can survive, like a lightning strike or a short, sharp IEC EN 61495. These are certification numbers that indicate the contactor meets specific international safety and performance standards. 230V AC. Control circuit runs on 230 volts AC. Let's find the right contactor for your job. Need to run a standard 3-phase motor? Go with a 3-pole contactor. It's the classic choice for motors, fans, and compressors. Add an auxiliary no contact, and you can easily light up a motor on indicator for instant feedback. Need to switch a neutral line too? Pick a 4-pole contactor, perfect for generator transfer switches, UPS systems, and anywhere full isolation is critical for safety. Need smart control between 2 actions? Choose a 2NO plus 2NC contactor, ideal for automation tasks like elevators, safety interlocks, or any setup where timing and sequencing are key. In short, the right contactor makes your system smarter, safer, and more reliable. Alright, here's the quick cheat code for picking the right contactor. First, voltage. Check the coil voltage needed to activate the contactor and the load voltage that the contactor will switch. Getting these right ensures the contactor works safely and reliably. Second, current. Make sure the contactor's current rating matches or exceeds the full load current of your equipment. This prevents overloads and ensures smooth operation. In short, correct voltage and current ratings. A contactor that performs safely and lasts longer. It's important to know, a contactor alone doesn't offer any real protection. It's just a switch, a powerful one, but without protection features by itself. That's why we combine contactors with safety devices. Overload protection, short circuit protection. These devices protect both the contactor and the connected equipment from serious damage. So next time you see a tiny contactor symbol in a complex schematic, don't just skim past it. That little box is handling high voltages, executing your commands, and making sure your systems stay efficient. If you enjoyed this video, don't forget to hit the like button and subscribe to the channel for more lessons. This is Abdul from Eedemy saying thanks for watching, stay safe out there, and I'll see you in the next video.